Okay, do you guys see it? I know Abby got a head start.
Yeah.
Are you there?
Yeah.
Okay, so you're going to do the first one. We'll call that A. I'll put letters next one. Yeah, right now. In different colors. Let's make sure we cover all our bases. Okay, so Abby has A. Let's see.
Okay.
I'm gonna give Leah B. Jesse has C. Simpula has D. Cameron has E. Gonna give Gracia F. Israel's G. H is Jessica. And I will be Mauricio. That's everyone. Yeah, you can write them on the board and I'll have to translate to Abby. Or can you see it? Can you see the board, Abby?
Yeah, I can see the board. Kind of.
Kind of.
I
We'll
can only
adjust it
see
so you
half
can-
of the board.
we'll adjust it to see. When it's time. Okay. Guys are more than welcome to come up and start. Write it close by, because Abby will be able to see it, and I don't have too much to translate. So, just a heads up, as of right now, slides are supposed to be coming in.
Do you want me to draw mine?
Yes, slides are in. The slides are supposed to be coming in, those slides are supposed to be coming in. Slides coming in, and so they were supposed to be delivered today, sometime today. Supplies for this class. So we don't have too many, or we have a lot of organic material, but we don't have the right organic material. And so we're waiting for it to come in. We may do a lecture on Wednesday, but I'll know for sure later on today. Wednesday, it looks like now Wednesday's gonna be a lot. Okay, but if the slides come in, we will do a lab. I want to try to keep them balanced. So we can only do split. One, two, three, 5. Okay. Looks good so far. 7, yeah. Try. It doesn't matter. Where is the finger at? Yeah. No, it's okay. I'm giving you guys credit that I give you just enough, and hey, pushing the water. You got them. There's the plan. The last thing. Yes.
Okay, I don't know if I did mine right.
What was that? No,
Can you see mine? I don't know if I did it right.
yes, yours is right. That is correct. Look at it again. Look at it again. What is the longest chain?
Isn't it this one the longest one?
The longest chain? Longest chain. I mean, the longest chain of process. That isn't the longest chain.
Oh, you mean like starting like from Australia?
Yeah, so where's your one?
Over here.
That's not the same.
One,
One, two.
4, 5, and 6.
Okay, so what is the six chain called?
Isn't it a hexane?
Hexane.
So,
So that's because it's bigger
so it would be over here would be 6 then. Over here.
than
Okay,
no, that's two. But your cycle hexane should be cycle.
hexane.
This would be hexane. This would be hexane. So you can't have hexane. You're going to have your cycle pentol in the beginning. Because this is the side chain right here. So this is going to be your side chain. Okay? And that's going to be after one carbon. And that's that cycle pentol. You want to have that cycle pentol. So it's YL. Okay. So it's 2-methyl, 1 cycle pentol, and then hexane.
And then I put one over here,
Like, okay, so put your dash, you have the one there already.
and then.
Oh, I see what you're saying.
Yeah.
This is a L, okay. So put your L and then put a one between.
Yeah.
Use that.
And then, okay, so it would be
Methyl, right, two methyl,
methyl, and then the dash,
dash one,
cycle.
dash, like, pencil, cyclo. Cyclo, yeah, cyclo, and Y, TYL. Okay, and then put your L here. Okay, and then it's hexane. And now it's hexane. Well, use the right here.
I didn't feel like sure. The
Okay, that's it. Hexane.
Oh, okay. I see.
Yeah. You're All right. Yeah. Yeah, because you counted the ring, right? The ring is the attachment. So. Oh, that's the first. Let's see. That's an interesting way of doing it. Let's see. So where would be your one, two, okay. But when it be that is one. I thought about that. That's fine. Well, it's still be one, two. And then, so would this be isobutyl or would this be isopentyl? Oh, okay. Pentyl. Propyl, sorry, propyl, pentyl is fine. Okay. Okay. Can you use that one next time? Can you use that one next time? Okay. Are you forgetting something? Where's that methyl at? Good. Who had the, oh, not me. Did I give somebody? Yes, that's so tiny. Yes, I did give you. Oh, well. Oh, okay. I was like, where is he? Okay, good, good. Yeah.
For letter A,
Mhm.
I don't know the same answer.
Okay.
I put one parentheses, one methyl. And then ending with the parentheses, four parentheses, one methyl propyl cyclohexane.
Okay. You say you put one methyl ethyl.
Yeah.
Okay.
No.
Okay, 1 dash. Oh, where they're located at? Okay, so it would be incorrect because you want to try to go in terms of that priority, right? So I guess I see what you're saying. You're saying you're starting out with the ethyl, right? You're using the ethyl as your starting factor. Okay. And so let me think. So technically that would be correct. Yeah, so you're just switching those parts. 1 and 4. I'm doing that. 1. And this is 1. Okay. It does matter. Yeah, technically it should. So you're right. I gave her the wrong answer. And I think she had it right at first. So it's going to be based upon because both of these are about the equivalent, right? There's not more structures that are hanging off here, right? So then it's going to be alphabetical in that case. So then it's going to be E opposed to your P. So like they're almost equivalent, but that E has priority because it's 4 or P alphabetically. So they're not the same. So technically, yeah, we've got to remember the hierarchy of it. So remember, the more, we want more because it makes it easy. And then we want alphabetical. And so since more meaning like more functional groups hanging off, not more length. But I understand your logic. I want to agree with your logic because, you know, it's easy. It should be alphabetical, so then it's M. M should be back here, ethyl should be before. So, yes. So yours is correct, but it's alphabetical. Yes, you gotta change alphabet. I gotta remember all these rules myself. I'm rusty. See, Sampula has an advantage on us. It's a little fresher for her. And which one? You could have put, yeah, well, you could have got 1 methyl ethyl. So if you put 1 methyl ethyl, then it should have been the ethyl, then the methyl ethyl, and then the dimethyl. Okay. But this would be acceptable as well. Yeah, it's all of the right? So again, flashcards help with all of the the more you see them, the better you get at that. Okay, so how are you guys feeling on this? You guys are looking pretty good. We just got to get those fine tuning, those little rules that we keep forgetting. Alphabetical. So more functional groups, alphabetical, and then the order. So if they're both ethyl, then the ethyl alone goes first, then the methyl ethyl, and then if there's, you know, so and I have to figure out, of course, so we want to make sure we want the lowest number possible. Okay. Can you see all of those, Abby?
Did I get them right?
You got yours right. Yes, you did.
Oh, yay!
Can you see theirs?
Yes.
You can see all their answers.
Yes, I can see theirs.
Okay. Even though their writing is about this thing, Israel, Like you write bigger on the paper than you write on. Okay. Okay, so let's get started. No. Okay, so we've kind of skipped over a couple of things. So we started with using the stick structures, total structures before we started using the condense. I hate using condense because I hate writing out all of the carbons and everything like that. But you need to be able to do both. You need to be able to do them all and recognize them all. So we're going to go back a little bit on that until you guys get used to doing that as well. So as much as I hate to, got to get it done. So we're going to do a little bit of practice on that, but not right now. I want to go ahead with support. So let me get the new screen up. Okay, so here, this guy is going to represent our primary carbon. That's going to be our very first carbon. So this is the halide that is on our primary carbon. And then that's the continuation of the hydrocarbon. Okay, so here, this would be our what happened? This would be our secondary carbon. So then that means that our halide is on our secondary carbon. Okay, and then this guy would be a tertiary carbon. So this would be a tertiary halide. Okay, so if it's primary, basically meaning that your halide is at the end of the carbon chain. So you have a carbon and then you have a halide. Here, your secondary is when the halide is on the chain, anywhere on the chain other than the ends. Okay. And then tertiary is you have groups going on all sides, and then you have a carbon, and then your halide is there. Okay. So like in this case, you have a hydrogen. In this case, you have other hydrocarbons. So not a hydrogen there. Okay. So these would be other carbons that this carbon is attached to. So like a branch point. Okay. Yeah, good look, Jesse. Okay. Okay, so the common name versus the systematic name. We've already talked about the common name. You know, we would use just the carbon chain, the length of the carbon chain, and then you would just put chloride. Okay, the systematic name, we would put chloro. In this case, we don't have to put the location because it is a terminal halide. Okay, so it's understood to be one. Okay, so here's the same example. This is ethyl fluoride. Again, because it's a terminal halide, then meaning that it's at the end terminal, then we don't have to put the number 1. It's understood to be 1. Okay, now here, the halide is on the second carbon, right? So is this a secondary carbon, or is this a tertiary carbon, or is this a primary carbon? This carbon right here, that the iodide is on. It is a secondary, that's right. And so since it's a secondary carbon, okay, we're gonna actually, we would call this guy, since this guy is iso, because it's a carbon, and then another carbon, so that would be our iso component. So this is isopropanol, isopropyl iodide, okay? And then, or we would call it 2-iodo-propane. You notice we put the 2 for the location of where the iodide is at. And so in the common name, in the systematic name, we drop the ide, we put O, and it becomes a side chain. It becomes a functional group. Now, in terms of priority, halides are the lowest of the functional group, right? So they're low, okay? So they're considered one of the lowest functional groups in terms of priority, which reminds me, print out. Okay. So here, this guy would be sec butyl bromide. So it's again, it's a secondary carbon, since we have a chain, and then the chain on the side, and then we also have. So in this case, it's again for the common name, it's 1, 2, 3, 4. So 2 would be the shortest distance. So then that would be 2-bromo butane. Okay. So questions? Yes. Yes. If you had a carbon chain sticking out, they're still considered to be lower than those, right? And so in terms of order, in terms of priority, alkaline halides are the lowest, right? Then it would be alkanes, and then it just builds up from there. Okay, but they're considered to be lower. So they're always going to be an O. They're never going to be an ending. Like alcohols, ethanol, that's an ending. So in terms of priority, okay, I like to look at it like when we talk about priority, the higher you are in priority, you take that last name, right? And so usually you'll take that last name. There are exceptions. There are going to be exceptions when we talk about this. Okay. As with chemistry, there's always exceptions. Okay, so here are 5 different alkaline halides. I'd like you guys to go through and name them without looking at your notes. Just look on the board. Yeah, I've got to start fixing up these damn notes. Because you don't use the examples as examples. So now I would like you guys to name it name it with their systematic name, and then and the other cases try to name it with both systematic and common. Yeah. Easier? It's harder? I disagree, man. I think systematic is so much more easy. No, the common name is the one without numbers. The common name is the sec and the iso and the tet. And then occasionally what we'll do, we'll throw common like side chains. We can use side chains, we can use common names. Yeah. Yeah. Looks like for the first one, do the systematic. Okay. First, second, and then the third one, do actually do systematic for all of them. Make it easier. Just go do systematic for all of them. No common names. Okay, so let's start working through it. First one. Let's go with the common name. Oh, never mind. Go with the systematic name. Right here. Are you there, Abby? Say A.
It's hard.
Okay, what are we gonna do? Tell me the rules. Where am I gonna start counting?
From the smallest to biggest.
Smallest to biggest?
Yeah.
Okay, so what is my smallest to biggest? I'm gonna start this side, I'm gonna start that side, I'm gonna start, where am I gonna start?
You want to start on your left side.
On my left side. On this side?
Yeah. Right?
So 1, 2, 3, 4, 5, 6. Is that gonna give me my lowest numbers?
No.
Okay, 1, 2, 3, 4, 5, 6. So which number should I be using, the pink or the yellow?
The pink.
That pink. Okay, so if I'm using the pink, so how would I go about naming this guy?
So it would be
Okay. Sorry. It would be
2. Wait, 1, 2. Methyl? Wait. No. Hold on.
So what's on the 2 carbon? You just told me we're going to start over here with the pink, right? So what is on the 2 carbon? What's coming off the 2 carbon? What's that? Bromo. That's right.
Yeah, bromine, whatever it's called.
Okay, so we have 2 bromo. Come on. Bromo. Okay. And then, so that's 1, 2, 3, 4. 4th carbon. What do we have coming off our 4th carbon?
Another carbon.
Okay, so what do I call that guy? That another carbon that's coming off
Would that be di?
right here. What is this?
Wait, that's 1. So that would be, hold on. Methane.
Okay, so if it's methane, do we use methane or do we use
You use meth? Hold on.
methyl?
Methyl.
Yes, methyl. Okay, and my longest chain was how long?
6.
So 6 chain carbon.
That's hexane.
Okay, so what are you cooking us? Because I hear spatula scraping.
Oh, cooking. That's my mom.
Okay, what's your mom cooking us? Because I hear a spatula scraping.
I have no clue. She's in the kitchen. I'm in the dining room.
Okay, what about this next one? Come on, Israel. Where am I going to start counting from? Left or right? Okay, so you said from the left. So you're saying from here. 1, 2, 3, 4, 5, 6, 7. Or would I be counting from here? The yellow, which is 1, 2, 3. Can you guys see the yellow? 4, 5. Can't read my writing, but can you see the yellow? 6, 7. We're going to be starting from the right because lowest number. Okay, so we know that if we're starting from the right, we're going to call this guy 1 chloro.
2
6
di.
dimethyl. Okay. What's that? Okay, so what about the next one? This one right here. See if I can put it in the spot. There we go. It actually looks really good. Okay, what about this guy? Okay, Mauricio. You said one ethyl. Two. Iodo. Yeah. I. Cycle. Okay. Okay. Why was one ethyl and not iodo? Mm-hmm. And then I said priority, right? Yes. Halides. That's right. Yes, but you want to be careful with how you say that because the thing is that you want the lowest number first. Try to get the lowest number. But if you have options where you can start, because we have an option where we can start, right? This could be one, this could be two. So then you want to start with the one that has priority, right? When you have options, yes. Okay. Let's see. So that's all. Okay, let's do this one here. Okay, Sambula. This one right here. Okay. One bromo, ethyl, cyclo, pentane. Okay. Why didn't I have to put the location of the one bromo? Why didn't I have to put this in comments? Or do I have to put it in comments? I mean, not comments, parentheses. So it should be in parentheses. So you're saying, okay. But I didn't have to put where it was located at on the one carbon. Why? Because that's the only functional group, right? You're assuming that it's the one. Okay. Well, is that? No, you wouldn't hear if you did. Okay. What about the next one? This one right here. Leah? Four bromo. Two chloro. One ethyl. Cyclohexane. Yep. Yes, ma'am. Gaseous. Okay. Piece of cake? Okay, so now let's get to these guys. Give me the common name and give me the systematic name or the IUPAC name. Start with the one down here. Give me the common name. Common name. Propyl. Would it be just propyl? Look where it's at. Sorry, iso. Isopropyl. Fluoride. Okay, what is the systematic name? So 2-fluoro. No yawning. It's not allowed. Oops. It depends. I always screw up. So personally, I always screw up on fluoro because I always put the O before the, or I forget the damn U completely. Yeah. But yes, I should mark you down on spelling, but it won't be too bad. It'll be like a little bit of a point. But you know, the machine does when it grades you, it marks it all wrong. So there are going to be multiple guests, yes. Like Canvas. So because it's strict, it doesn't have any flexibility unless I enter all of the possibilities of how you misspell it. Yeah. Yeah, it's what I typically do, and then I'll give you points, weighted points based upon it. So I'm gonna spank your hand because I want you to get better. Because when I say I don't count spelling, you should see some of the spellings I get. I'm like, okay, yeah, I won't even tell you. I'll wait it. Okay. Okay, what about this guy? Common name? For wait. This guy here? Oh, okay. I'm like, no, so that was way wrong, you know. That isn't even close to misspelling. Cyclo, hexyl, bromide. That is correct. Okay, and the systematic name? Or we could just say bromo. Cyclohexane. Why don't I have to put the one? Okay. But it's okay if you do put the one. Okay, what about this guy? Common name. Turk. Are you sure it's Turk? Let's see. Yep. Sec-butyl. Sec-butyl. I could spell butyl chloride. Okay.
common name when you call it out?
Pardon me?
Like, you know, when you do a problem,
Uh-huh.
are you gonna give us like the common name and then?
Yeah, I'll do both. Sometimes I'll give you common name and sometimes I'll give you systematic name. Common name? Yeah.
Systematic concept, yeah.
I think I influenced you guys because I really hated systematic. Because that was okay. Okay. Thank you. I'll keep that in mind. I'm gonna have Sapula make my test from now on. Yeah. No, I typically I give you guys both, you know, or I will. Okay. Now it's systematic name. Sorry. So 2-chloro, 2-chloro, butane. And this time we have to use the number because it isn't on the first one. Okay, and this guy up here. Say it again. You said what? Common name. Is it sec? Look where the iso. Yeah, that's right. Iso. Six. Uh-huh. Uh-huh. Iso, that's right. If it's just, but it's got to be short tail, it's got to be 1 and 1, right? So just, yeah, that's right. Iso is always just that 1 and 1 in the corner. So iso, what is this iso what? Okay, hexyl, yep. Isohexyl. I'm just typing and where is it going? Isohexyl chloride. Oops. I think I need a new computer because my keys don't work all the time. And certain keys, often I have to press really, really hard. Okay, what is the common name? I mean, the systematic name? Said 1-chloro. Chloro. 1-chloro what? 4-methyl. 1, 2, 3, 4, methyl. Pentane. So that's 1, 2, 3, 4, 5. Okay. Piece of cake. You don't like the common names? Yeah. Yeah. Because I always have trouble, like the trouble with the sec and the tert. Those are the ones that I see. The iso is always like, okay, got the corner. You got the corner piece, right? Okay, or side piece. So I got that one down. And then neo is easy because it's just a straight line. So, and then, but I have trouble with the tert because I always forget, okay, yeah, it needs to be another hydrocarbon. And then whatever your functional group is off of, hanging off of that. And then the sec is, it's similar to the iso, but it can be any length, right? And so it's just off a secondary carbon. So you could try to name something sec that isn't truly a sec, right? But it works out for this one because it's the second carbon in this case.
The 1,466 dimethyl would that be a first?
Yeah, that's an iso.
No.
Oh, which one?
That's it. Yeah. No,
This one here? Yeah, so that would be a tert because you have hydrocarbon, 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 and then this the last hydrocarbon. So, but then you would call this tert what? But the thing is that the hydrocarbon isn't hanging off of the tert, so you'd have to name this a little bit different, but you can use tert as a way of naming because of this functional group. You can, yes, but it would be nasty. Yeah, technically this guy has to, actually this guy would have the potential of 3 names because you could use the tert, or you could just use the tert version, or you can use, it would have 2 potential common names. So. Yes, but the only problem is that you couldn't say tert oxyl chloride, so you'd have to break it up into 2 different parts, because this here is at the end. This tert could technically be here, or it could have been here, or it could have been there. So yeah, you don't. That's what you do. You don't. In that case, you try to avoid it because it's not functional. You can't distinguish between them. So if you try to use tert generally, then it's going to give it the wrong name, you know. So you would go with the systematic name. Yeah. No, in this case, you wouldn't do the common name because, so you could try to do the system, like I said, you could do the systematic name. It has 2 different systematic names, but that systematic name, you got to be careful, make sure that you're still obeying the rule. This guy has too many carbons to do that, right? Because this tert could be here, it could have been here, it could be here, you know, so it could be anywhere. And then those length of those carbons can be anything, right? Yeah. Mhm. Yep. Yeah, I get it. Yeah. So that's like, I would always say, start off with the systematic name. The ones that are easier, right? These are easy to do with the common name, right? If it has too many carbons, you can't use the systematic name. You can't use the iso. Well, you can use iso, but you can't use the tert, you can't use the sec because you have too many carbons. Like, so I think it's after, for bute, it's after, well, it works on bute. So all of them work on bute. Hex and pent. Pent, you can't use sec. And then hex, you can't use sec or tert. It gets, yeah, too many carbons. Yeah. Yes, there will, because I said there would be a question on the test that would ask you that. So getting there. Yeah. So when I'll give you guys a couple of homework, you know, a lot of homework problems, like maybe 100 or so, to kind of help you guys out with these. I'll tell you, I want 2 names. If I want 2 names, that means I want a systematic name and a common name. Okay. If I want 1 name, it's whatever you want. Usually systematic. Okay. Clear. Okay, so let's move forward. Okay, so ethers. So this is the ethers. This is the generic form for ethers. So it's a hydrocarbon, an oxygen, and a hydrocarbon. Okay, they don't have to be symmetrical. This is a symmetrical ether, basically meaning that it has the same hydrocarbon on both sides. So like if I had ethyl, diethyl ether, if I have ethyl methyl, right? So then it would be ethyl methyl ether. Okay. You guys see that difference between a symmetrical and a unsymmetrical ether? Symmetrical meaning that it's the same hydrocarbon on both sides. Unsymmetrical meaning two different hydrocarbons. Okay. Okay, so let's do this. So this guy is, what was that? It's unsymmetrical. Okay, what would be the name? And the way that we normally name it is we name it by, and this is the common name. Okay, this is the common name. The common name, we go by what's on one side and what's on the other side, right? And then we put ether at the end. Okay, so in this case, we have two methyl groups. So then we call this guy dimethyl ether. This guy, we have two ethyl groups. So we call this guy diethyl ether. This guy has what's over here? And then over here. Okay, so then this guy would be called so alphabetical. Ethyl, methyl, ether. Okay. Simple. Okay. Okay. This would be the next priority. Yeah. Where it the book. No. There's no logic to the book. Unfortunately, there's no logic to the book. And I'm just going in the order of the book right now because I haven't had, times and times again, because there's no logic to the book. And it drives me crazy. It drives me crazy because I wouldn't have, the fact that you guys did, my opinion, the fact that you guys started out with acids before in chapter 2, right? I mean, it kind of made sense to kind of reintroduce you to things, but I thought they were just going to reintroduce you to it rather than going over how to use these acids for things that you haven't even really talked about nomenclature wise, So I would have gone through nomenclature first and then gone to the functionality, but that's just me, and I'll change it eventually, but first time using the text, so it's a little rough. It's kind of like, if you guys took 2A with me, I switched up 2A and I'm switching out 1A now, so it's the parts of it I don't agree with going first as well too. Doesn't make sense. Okay, but these are the ethers, real simple, right? So let's see. I'm going to put some up here, and then I want you guys to give me names. Okay, we have. Let's see. Give me the common names, yes, because that's all we've talked about right now. And then we'll get into the systematic names. Oops. Okay. What would this guy be? Common.
But I feel like is it like
Iso. Isopropyl. Okay. You said tert. I'm just writing down what you're telling me. Butyl. Is that correct? Are you 100% sure? Think about the order. That's right. Butyl's going to go before propyl. Other than that, it is correct. It's not letting me. Okay. Okay, so a little heads up. Most people use the common names for ethers because it's a whole lot easier to remember than systematic. We'll talk about that in a minute. Okay, so. Okay, let me give you another one. Let's do. Okay, what about this guy? That's a 6-ring structure. It doesn't have a hat. Well, technically, let's give it a hat. Give it a hat. Double hat. Yeah, it has 2 hats. Yeah. This was a long chapter. Oops. Okay. You guys got an answer for me? Yes, no, maybe? Okay, what is this here? What will we call that guy? Cyclohexyl. Okay, and is there something else that we need to add to it? Okay, so how do I say that? So is it the second carbon? So you're saying, okay, so the ether has priority. And the ether is off of the, yeah, so that would be 1. So then that would be 2. So then what we call this guy? So it'll be 2,2 di methyl cyclohexamide. Okay. And then on the other side, isobutyl. That's right. So would the butyl or would the hexyl go first? Butyl. And that's ether. Okay. That would be its common name. Okay, so normally you wouldn't have numbers, but you'd use your iso, but you have to use numbers in this case to define it because you do have, so you're using, it's a common name because you're still in ether, right? But you have to use numbers to let me know that there's the methyl hanging off of the cycle group. So you can use a blend, essentially. Yeah. Or I get it, or tertiary, but it's all in that cycle. So it'll still be cyclo. But I understand what you're asking. Yeah. Okay. Let's see. Let's move forward. Actually, let's take a 5-minute break. PP break, coffee break, snack break.
Okay.
Okay. Ask mom what she's cooking us.
Definitely I'll ask.
Okay. Okay. So we talked about the systematic name. So the systematic name is this guy serves as a functional group, right? So one side would just be the functional group. So like this guy would be, it would be methoxy. Okay, and so depending on what it's attached to on the other side, if it's a longer chain, then that gets the base. So then if it was let's say it was pentane on the other side, right? So then it would be methoxy pentane. Okay, so let's say, yeah, yeah. So this part here would be, because this part is just the meth, it's one carbon, right? And then it's an oxygen, so meth, oxy. And then if this guy was, let's see, CH2, 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 CH3. 1, 2, 3, 4, 5. Okay, so then this guy would be, as I said, methoxy pentane. Do you guys see that? So, and then, so this is the systematic name. So this is how it differs. So ethers are going to be different because all it is that you're putting in an oxy at the end of that root. So this guy would be ethoxy. Okay, this guy, since it's 1, 2, 3, right? And you would call this isoperoxy. And this guy, 1, 2, 3, 4. So then this is what type of common name structure we have in this case. Sec-bute. So this is sec-butoxy. And then this guy would be 1, 2, 3, 4. Tert, that's right. Tert-butoxy. Okay. So, no, this is the systematic name. Okay. So systematically, if you look on your back of your handout that I gave you guys, not that one, not this one. Actually, you can look on this one, but if you look at ethers, right? So prefix acyl oxy. So that is the prefix that you're going to be using for it, right? So you put OXY after the carbon chain, right? The smallest carbon chain gets the OXY, okay? So if you look on the back of your periodic table, that packet, the very end, it gives you all of the functional groups. Are you there, Abby? Let me get up a whiteboard.
Yes.
Okay,
I'm here.
let me pull up a whiteboard real quick. Okay, so we have, okay, so the small chain gets 1, 2, 3. So this guy has 3. So then this guy would be called propoxy. And then 1, 2, 3, 4, 5, 6. So 6. What's the 6 chain carbon? 6 chain. Hexane. Okay, so that guy would be called propoxy hexane. So all you're doing is putting in an OXY. So that just means that you're putting oxygen there, right? Makes sense? Okay, one side, the small chain always gets the OXY. The large chain gets the, okay? So now, because we're idiots, we will mix the common name and the systematic name, right? And so you get it's kind of like Spanish, right? Spanglish, right? Spanglish, we speak Spanglish. Oh, yes. See, oh, yes, yes. Okay, so we will speak Spanglish, right? Or slang, slang and regular English, right? We speak slang in English. So we will actually do the same thing with chemistry, right? So in this case, we have okay, what would this guy be called? So tert what? Tert butyl, but it wouldn't be tert butyl, it'll be tert butoxy. Yep. But butoxy. Buttocks. Ah, nice. I didn't think about that. And then 1, 2, 3, 4, 5. Heptane. What did you say? Heptane? You said pentane? Pentane. You said pentane? I'm like, okay. Let's see. Pentane. Okay, not too bad. Yeah, although I like the ether one because it's this one and it's that one. It's an ether. Not too hard, right? I always forget about the oxy because then there's also oxo, which we'll be talking about here later. Don't worry, it's all fun. Fun until somebody gets hurt. Okay. Somebody's gonna get hurt. You're like, it's too late, somebody already got hurt. Okay, so if you look on the priority, I guess they are sort of going in it, but we've talked about alcohols, but we're going to come back and start talking about alcohols again, apparently. Okay, so we're working our way up gradually, although, and we've kind of talked about amines, but we talked about amines a long time ago, right? So, yeah, we'll figure it out. We'll all figure it out. Okay, so you guys want to try a couple of them? I'll put some names up and then this is the systematic. Don't fight it, embrace it. Okay, so let's see. Okay, I do train you to fight it, but you're right, you're right. Okay, so we'll start off simple. So give me the common name and the systematic name. You guys ready? You got them all? Who's that? We can do the first one together. Come on, we can get this one. All right. What is this? Common name? Ethyl. Methyl. Ether. Its systematic name? Say it again. Methoxy. Oh, I'm really typing stuff, but it just does not. Methoxyethane. Okay. This guy. What was it? I see propyl. It's common name. Let's do the common name. Iso. Iso what? Iso what? Use the isopropyl. Iso. Pentyl. Those should be before pro, isn't it? Just saying. We did. Oh, you're talking about here? We did. Ethyl methyl ether. No, it goes by small chain. So this is like a side chain. The methoxy is a side chain. So the longest chain. Okay, so then what's going to happen in the case of the longest chain is the end. there's a couple ways that you can do it because we can do Spanglish. I mean, Okemish. Yeah. Okemish. I don't know what to call it. Commonish. Common system. Com system. I don't know. Com something. Yeah, systamen. Okay, so let's see if we can do systamen, and then we'll do just straight systematic. Come on, we got this. I want systamen, and then straight systematic. We just did common. Now you need to do systamen, and then we'll do systematic. So technically 3 different ones for this one. You're lost? That's right. Yeah, we're adding iso to the systematic. So we're using common and the systematic on them together. So how would I do that one? Isopropoxy. Isopropoxy. Isopent, that's right. Isopentanol. Isopentane. Yes, it might. Got to be prepared. Isopropoxy, isopentane. Yeah. Iso. Okay, and then systematically, this would be called one, two, three, four. 1, 2. What was that? So where will we count from? Where will we start counting? So that'll be 1, 2. Okay. So if that was 1, let's see, and put the numbers up. So this is 1. This is your 1 carbon. That's your 2 carbon. What was that? Then this is 1, 2, 3, 4. What's that? Okay, so you're saying we're substituting what? One, 2 is butyl. Ethyl. Okay. Okay, ethyl. So we got Miss Ethel. Okay. Okay, so we have 1 methyl ethyl. But we don't have, it won't be methyl ethyl, it'll be methyl oxy. Okay. Mm-hmm. 1 methoxy, methyl oxy. Okay, so we have 1 methyl oxy. Mm-hmm. Okay, but we need to add something else to it. Three methyl. 3 methyl. Okay, so it's 1 methoxy, methoxy, 3 methyl butane. These are such beautiful names, aren't they? Methyl ethyloxy. Okay. You will. Yeah. Okay. What about this guy here? This one? Its systematic name? Mauricio is offering? Is that what he's saying? Okay, so you said you oxy. 2, 3 methyl. Oops. Methyl pentane. So what would be its common name? Or would it have one? Butyl. So we'd have a butyl. B is for P. B is for P. B before P. You said pentyl. You said 1, 2, 3. So it'll be 2, 3 dimethyl. So that would be in parentheses. 2, 3 dimethyl pentyl. Ether. Ether. Okay, what about this next one? This one down here. Let's do the systematic name. Or the Spanglish, the constemic, the constemic name. Okay, so you said methoxy. Okay, so we have You said 1 methyl ethyl ethoxy methyl ethoxy actually we should have done this. Hold on. Correct. And you said 1 methyl propane. See, that's 1, 2, 3, 4, 5. Are we looking at the right one? So that's the 1 carbon. Okay. 1, 2, 3, 4, 5. 5 chain carbon. But we have to first put that. One methyl pent beautiful. There we go. Okay. Is there a common name for this guy? Isopropyl. Okay. Okay, is that alphabetically correct? Okay. So could I use sec pentyl here? Sec pentyl. Could I use, or I mean, sorry, not sec, hept pentyl. I know, sec heptyl. Is that 1? Let's say 1, 2, 3, 4, 5, 6. No. Hexyl. Sec hexyl. Can I use sec hexyl? Could I use it? Are you sure? No, you're not sure, or no, I can't use it. Why can't I use it? That's right. Too many carbons, because that sec could actually be here, or it could have been here, or it could have been. How much is too many? Okay, so the rule typically is that after 5, so 5 works great for sec, right? After, but it doesn't work for tet. Okay, is that right? No, 5 work great for sec. No, 5 work for tet, but it doesn't work for sec. And then 6 doesn't work for sec or tet. So 6 carbons, it doesn't work for sex or tet. or TERT, sorry, TERT, not tech, TERT. I'm in the ec right now. Okay, so let's do these structures real quick. I know we're over time, so let's do one of the structures. Which one? Let's do this one here. This one is fine. It's 1,4-diisopropyl-propoxy butane. So the easiest thing to always do is to start off with what? Longest chain. Okay, so it's 1, 2, 3, 4. Okay. So it's 1,4. So dioxypropoxy. So we have an oxygen here. Okay. Isopropoxy. So what does that mean? So it should be like this. Okay, we got an O, diisopropoxy. It has 3 hands. Okay, so that's 1. Okay. 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 On the other side? Are you sure? Okay, but it says it's, what does that mean? And it's 1, 4. Where are they located at? Carbon number 4. So we're going to have another. Yeah. 1, 1, 2, 3. Okay. Okay, so then that's 1, 2, 3, 4 carbon. You have 1 on this side and then 1 on that side. Do you see it? Yeah. Okay. This one is an easy one. All right. What is it going to be? Well, sort of easy. It says 4-methoxy octane. So what is that going to look like? So we start off with longest chain. So that's 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4. What's off the 4th chain? Is it going to be just the meth? It's going to be the oxygen. Then there's going to be a meth attached to it. You said I got to practice. Okay, so we'll leave this one for you guys to do. You gotta remind me, and we'll leave this one for you guys to do. You gotta remind me. Okay. So I'm gonna let you guys go. Peace. And then hopefully we'll get through a little bit more. This is a long ass chapter. All of nomenclature in a single chapter. I'm just gonna shove it all in. Okay. I will see you guys mañana. I mean, no, I won't see you tomorrow. Wednesday. It all blends together to me. The week never ends.